So let's start with hydrogen. So hydrogen has a certain value. Right now, we are not going to work with values. Instead, we're going to work with uh, the value of the ionization energy and see if it will rise or it will fall. So let's suppose hydrogen has a certain value and the electron goes in 1s because that's the lowest available one. And that's hydrogen. And now we are on to helium. So helium has 1s2. It has two electrons, both of them going into the hydrogen's electron goes in 1s, and that's over here. So it has a certain value. Let's call that value A. Now, helium will obviously have the second electron, and that should go somewhere here. Do you think the ionization energy of helium would be higher or the ionization energy for hydrogen? Which one? Remember that ionization energy is the energy required to remove the last electron that you have right now. So for helium, it will be the second electron, and for hydrogen, it will be the first one.
So for helium, it'll be higher.
Why is that?
It might be harder to remove an electron from like a full shell because that's more stable.
Good, very good. So helium has a full shell, which means there's an increase in the first ionization energy for that. Again, we're just looking at the first ionization energy here. So it will be harder to remove this one. Now, if we compare the hydrogen atom with the helium atom, then what factors are there? Number one, helium has more protons. Okay. So what does that do to the atom? So helium's atom would be smaller because if I have hydrogen atom, which is like this, and roughly the same, but now I have helium atom. So this helium atom, if I were to compare this, the because of two what you call protons, the size is going to be slightly smaller because these protons are going to pull on this electron much more than the one electron in hydrogen. That's one. So because the distance decreases, the ionization energy increases, it pulls it more. Now, while we do say that, oh, helium is more stable and it has a complete shell, they're just different shortcuts that we have to understand the underlying pattern. But when you are answering this in the exam, you can't say that it is more stable. You have to talk about physical things. Stability is just a general word. So the primary factor why helium's electron is difficult to remove, why its first ionization energy is higher and that for hydrogen is lower, is that helium is a smaller atom. And not just that, it has greater effective nuclear charge. And obviously, there's no shielding. As you can see, it's only the first shell. All right, so building on that, let's look at lithium, which is going to be 2s2. The last electron is in 2s2. So lithium's ionization energy, how does it compare to hydrogen? So we are expecting lithium to have two shells, okay, and one electron in this one electron in this one. So let's see how the atom's electrons go. So lithium has three protons. They're working for us. They're pulling these in, okay, so they're pulling these in, but there's also another shell, and that shell being there has introduced more shielding. So there's shielding there. The first shell is pushing the last shell, which means that last shell will now be further away. Okay. So while it will try to pull it, the last shell is going to be sent outwards because this is there is shielding. And the primary factor here is shielding here because the increase in protons isn't that much, but increase in shell is more significant. So there's more shielding, and the increase in the effective nuclear charge isn't that much.
So how do we calculate the effective nuclear charge?
We don't really calculate it, in AS. We
But
just
how do
try
we
to
know
compare it. How do we what?
like what it is or like if it's more or less?
So right now we can see that there are three protons, so effective nuclear charge is greater than that of helium. But it's also evident that it has another shell, and that shell is much bigger than the first shell. So it's going to go further away. So two main factors here. The charge is increasing, which will decrease the size of the atom, but the shielding is also increasing, which will increase the size. And shielding is the more effective one in this case. Okay. So shielding increases, and effective nuclear charge, that increases, but distance also increases because the shell is much bigger. So there are two factors that are towards decreasing the ionization energy: higher distance and greater shielding. Both of them decrease the ionization energy. And the only factor that decreases the ionization energy is so ionization energy is increasing because size increases. So उल्टा बोल रहा हूँ मैं, क्या हो गया? Ionization energy decreases because size increases and shielding increases. But ionization energy increases because charge or nuclear charge, it increases. So considering these, there are two factors and they outweigh the effective nuclear charge. And so ionization energy decreases. There's a large decrease. So yeah, we will expect that. And that's exactly what happens. If you look at the values, then first ionization energy of helium and all those were given. And you can see from the table that we had. So for hydrogen, the first one is 1310. For helium, it is 2370. And for lithium, it's just 519. So there's a rapid decrease. So the graph might go something like this. This is hydrogen, this is helium, this is lithium. Okay, fair enough. Now moving on. The the fourth electron now, beryllium. So beryllium has electron coming in here. How does beryllium compare to lithium? Let's see. So this is lithium. I'm going to make a copy of this. So beryllium now, 4 protons. With 4 protons and 4 electrons. Does the shielding change? Comparing this to lithium, does the shielding change? No, there is no shielding, right? So the shielding doesn't change because there's only one inner shell and the shielding remains the same. And what about nuclear charge?
So it increases?
Nuclear charge increases, yes. And what about spin pair repulsion? The repulsion that 2 electrons in the same orbital have for each other.
So I guess it increases.
It increases, yeah. So the repulsion increases, which means ionization energy decreases. The size decreases because nuclear charge increases. So beryllium is slightly smaller than lithium, which means because it's smaller, but it has roughly the same shielding, it's going to have, so shielding remains the same. So no change in that. So no change in ionization energy because of that. But the size decreases.
क्यों छोटा है?
Because there are more protons pulling on the same electrons.
So what does
Second,
repulsion have to do with ionization energy? Like if it increases, will the ionization energy also increase?
What factor are you asking about?
Spin pair repulsion.
Yeah, spin pair repulsion is that electrons that are paired up repel each other, which means it's easier to remove them. The ionization energy decreases because of that. But it's not that significant a factor most of the time.
I don't understand how it makes the ionization energy decrease.
Ionization energy is about removing the last electron, right? So if you look over here, this electron is what we're talking about, and it's being repelled by the other electron in the same orbital.
Yeah.
We want to remove it, and the other electron also wants it removed.
Okay.
Yeah, so they're working in sync. So now beryllium has a smaller size. Why? Because there's greater nuclear charge pulling the shell closer. But the shielding remains the same. So the effect of shielding is 0. Not that much. Size is smaller, so ionization energy increases. Charge is greater, so ionization energy increases. So no wonder the effective nuclear charge, the smaller size, both work together to increase the ionization energy of beryllium. So beryllium's ionization energy is going to be bigger than that of lithium. Now let's look at the boron atom. Boron, this is going to go into 3p. So the electron goes here. It is still in the shell, but it's in 3p. So what about shielding? From boron to beryllium. So this is beryllium now. और वो हमारा boron है जो नया atom आया है. So let's compare them.
So I think ionization energy will increase.
Ionization energy will increase. Not so fast. Slowly chalo. Let me remove these and I will try to just make two atoms that we compare with each other. We have beryllium here and we have boron here. Let me compare these two, okay? And these are the primary factors that we have. Okay, tell me, from beryllium to boron, what do you expect the size to be? Do you expect the size to be smaller or greater?
Smaller.
Smaller, yeah. Again, same factor. The size is smaller because there are 5 protons pulling on it. But there's also more repulsion. And this repulsion is not shielding only. It's also because of these electrons pushing each other away. One orbital pushing the other orbital. So basically, the last electron is slightly further away than the one in beryllium. Why? Because it's in 2p. So the distance between this 5th electron and the nucleus is slightly greater. There is more distance. Okay. And shielding is slightly greater because again, the last subshell is being repelled more by 2s. So shielding went up, so ionization energy decreases. Size went up, ionization energy decreases. Nuclear charge increased, but again, it's not that significant. So what would we expect? Again,
so does the shielding increase?
Why does shielding increase? Why does shielding increase? ये पूछ रहे हो आप?
जी sir.
So हमारे पास ये 3 factors होते हैं ना, इनको मैं देखता हूँ. So the shielding increases because the last subshell 2p is being repelled by 2s slightly. So one orbital of 2s is repelling the one for 2p. So there is shielding because of that, and obviously the shielding from the first shell, that's also there. So shielding increases slightly. Size also increases slightly because 2p is further away from 2s. 2s छोटा होता है, 2p उससे थोड़ा सा बड़ा होता है.
So size increases?
Size increases. Obviously 2p is bigger, 2s is smaller.
But sir, doesn't the size of the atoms decrease across the period?
It should decrease. That's what I'm saying. But over here, this is a special case. It does decrease in general, but over here, you have suddenly added another subshell, which is much bigger than the previous subshell. So if I were to look at the size of boron atom, Google gives me 85 picometer. But for beryllium, it is 112. तो थोड़ा सा decrease हुआ है, ठीक है? और वो हुआ है क्यों? Because there is what you call increased nuclear charge.
The effective nuclear charge also increases.
Effective nuclear charge increases, yes. So effective nuclear charge increases, which should bring the ionization energy.
मुझे इस वाले केस में नहीं समझ आ रहा कि साइज क्यों इंक्रीज किया है. वैसे हमने कहा
साइज इंक्रीज नहीं किया है, साइज स्लाइटली लास्ट शेल का इंक्रीज किया है. ओवरऑल साइज नहीं इंक्रीज हुआ एटम का, बट लास्ट शेल थोड़ा सा दूर चले गया because of repulsion from 2s. So 2p is being repelled by 2s. That's one. And both of them are being repelled by 1s. ये भी पता है आपको. So there is shielding.
Okay sir.
ठीक है. उसके बाद आपके पास so shielding बढ़ गई है. साइज थोड़ा सा इंक्रीज किया है 2s का 2p से. So what does that mean? So two main factors is 2p being shielded by not just 1s but also 2s. So decreases the ionization energy. उसके बाद the nuclear charge isn't that effective to offset that, to counter that. तो उससे क्या होगा? आपकी ionization energy decrease करेगी. यहाँ पे आपकी तो नहीं कहना चाहिए, the atom. So the ionization energy will decrease for boron. थोड़ा सा फर्क पड़ेगा. So try writing it down. Examiner has given you a question that why does explain the decrease in ionization energy of boron and beryllium. Go on, explain it. Write your answer down.
Can I say कि although the effective nuclear charge increases from beryllium to boron,
Mhm.
there's repulsion between the 2p and the 2s subshells, and therefore the shielding also increases slightly.
Mhm. Mhm.
And the size of the last shell also increases because of because the p subshell is bigger, so it's further
Mhm.
away from the nucleus, and therefore the electron is easier to remove.
That is perfect. You have talked about the size, you have talked about the shielding, you have talked about the charge not being that effective, and so there is a decrease. So you have talked about the three factors. Perfect. All right, let's move on to the next one. So this one is so for boron to carbon. Okay, so carbon's electron, where does it go? It goes here, right? So this one is a pretty simple case. What would we expect? Has anything changed from boron to carbon? Effective nuclear charge has changed. It has increased. Size has decreased because of nuclear charge. Size of boron is 85. Size of carbon is 70. Okay. And size has decreased. So we would expect ionization energy to be increased. Shielding roughly the same. Why? Because वही शेल हैं, वही सब शेल हैं, कुछ नया नहीं आया. Charge increased. So what do you expect? Ionization energy to
Increase.
increase. Yes. Increase. Yes. And that's exactly what happens. From boron to carbon, ionization energy increases. The answer for this is pretty simple. Now from carbon, now we have done carbon. We'll move on. So the next one is nitrogen. I'm sorry, carbon यहाँ पे आएगा. We are comparing them. So carbon, nitrogen. Where does the nitrogen electron go? It goes here, right? So what do you expect? Let me tell you the sizes. 70, 65.
Sure, so size decreases and shielding increases because
Why do you think size decreases? पहले मुझे ये बताओ.
because you wrote 70 and 65.
No, but how do you know in the exam that the size has decreased?
Sir, because across the period, generally size does decrease.
I'm not talking about a general case. I'm talking about a specific case from carbon to nitrogen. You should say effective nuclear charge increases. That's the reason the size decreases.
Okay,
What
sir.
about shielding? Have you added another subshell? You haven't. Have you added another shell? You haven't. So shielding is roughly the same. So what do you expect? Ionization energy increasing or decreasing?
Increasing.
Increasing. And that is correct. First ionization energy of nitrogen is higher, and for carbon it is lower. The values are, let me see. So carbon is 10286 and nitrogen is 1402. So yeah, we expect it to be bigger, and it is bigger. Yes. There you go. So nitrogen. All right, moving on from nitrogen to oxygen. Okay, so this is nitrogen, this is oxygen, an electron here, another electron here. G, what do you expect? Size.
It
What do you think?
decreases.
Size decreases. क्यों?
Sir, क्योंकि electron भर गया.
Good. Size decreases because effective nuclear charge increases. Good. What about shielding?
It remains the
Where does the
same.
electron go, by the way? Where does the electron go? In the
Sir, I'll go
top
into
arrows.
one of the two PX.
One of the two P's. Yes. One of the two P's. Yes. So now what happens?
But sir, because there's like repulsion between both of them, so it'll be easier to remove.
Yes, we have a new factor here. This factor is called spin pair repulsion. So the spin pair repulsion increases, which is another way of saying shielding increases. And when shielding increases, ionization energy decreases. So we see a small drop.
Sir, ये spin pair repulsion एक बार समझा दें.
So basically, you have a pair of electrons here, and these pairs, they are going to repel each other because they have opposite spins, so they repel each other. So there's an additional extra repulsion between this pair that you haven't seen before. So you will need less energy. Okay, the pair is pushing each other out of the atom, and you're also trying to do the same. So you're working together. So obviously it will be easier for you to do it. Okay, next one. We have oxygen ke baad. After oxygen, we have, what is that? Fluorine. So oxygen idhar aa jayega, fluorine idhar aa jayega. Fluorine mein you add one more, oxygen is there. And where does the electron go? Electron goes into another of these. ठीक है, वो यहाँ पे आ जाएगा. Oh, sorry, opposite. My bad. All right. So what factors are changing? Spin pair repulsion increased. Effective nuclear charge increased. Shielding not that much. ठीक है, roughly the same because you're just increasing the spin pair repulsion, and size decreased. So size is increasing. Charge is increasing.
Sir,
Both of them.
पहले
Yes.
केस में आपने कहा था कि स्पिन पेयर रिपल्जन अगर इंक्रीज करेगी तो शील्डिंग इंक्रीज करेगी, तो अब क्यों नहीं मतलब इंक्रीज की शील्डिंग?
Again, shielding को अगर आप स्पिन पेयर रिपल्शन के साथ कंबाइन कर दो तो तब आप कहोगे वो इंक्रीज करेगी. But you can also keep them separate. You can also be like, I have 4 factors instead of 3. And it's better that way. तो पिछले केस में भी हम ये कह सकते हैं कि स्पिन पेयर रिपल्शन इंक्रीज किया बट शील्डिंग फ्रॉम इनर शेल वो ही रही थी. So I should have put a upward arrow. I should have put a constant thing there.
Okay, sir.
Yeah. So I'm trying to keep them all 4 separate factors. So in this case, you have seen that size decreases, shielding is roughly the same, charge increases. Both of them will make the ionization energy greater, and the repulsion is there, जो कि उसको smaller करेगी. But the two main factors offset that, और fluorine की ionization energy ज़्यादा है. Notice that in any of these explanations, I did not say for even once इसकी stability ज़्यादा है, because stability is what we say when we don't know the answer. वो एक जनरल सी बात है जो कि ठीक है, गुजारा हो जाता है उससे. But in your exam, if you want to score marks, you will not use that word. You will go right to the factor that actually matters. Okay, and now we are done with fluorine and oxygen. Let's move on to the last one in this shell, which is neon. So fluorine and neon. So fluorine has one more and neon has another. So size decreases. Shielding roughly the same. Charge increases. Spin pair repulsion, yes, it increases. So again, no, this case is just like the case of fluorine and oxygen. पिछले case ऐसा ही है. So इसमें the size will increase. Neon ionization energy will increase. Now, one important factor. This is slightly less than the one for helium. Why? Because if you compare helium and neon, helium is still much smaller and neon is still bigger. उनको अंदर आपस में तो neon की easier होनी चाहिए. So this was simple case. Now let's look at the next one, sodium. Neon here, sodium here, and we are adding in our shell. Tell me, it is actually really easy. Why does it decrease?
Sir, because the shielding increases and
So the size increases,
shielding
shielding increases by a lot, charge increases by not so much, and spin repulsion doesn't change. So what do you expect? It will fall. बहुत ज़्यादा गिरेगी. How much? Slightly less than lithium.
सर वैसे अगर इलेक्ट्रॉन भर रहा है तो साइज डिक्रीज नहीं करना चाहिए था.
But we have added another shell.
Okay, sir.
Yeah, so the shell is much bigger than the inner shell. उनका size एक जैसा नहीं होता, बहुत बड़ा होता है एक दूसरे से. So you're right कि प्रोटॉन बढ़ रहा है तो साइज छोटा होना चाहिए, but the shell is so much bigger वो साइज छोटा होके भी इतना छोटा नहीं होता. And now you're on the third period and the same factors are going to repeat themselves. You can expect an increase just like this one, कि ऐसे होगा, फिर ऐसे होगा, फिर ऐसे, सॉरी ये होगा, फिर ये होगा, फिर ये, फिर ये, फिर ये होगा, फिर ये होगा, फिर ये होगा, जो कि इससे थोड़ा सा नीचे खत्म हो जाएगा. You can expect all of this. And then ये फिर गिरेगा पोटेशियम पे जाके. And today we'll just keep it till potassium, because after potassium आपके पास कैल्शियम है, उसने बढ़ना है, but then you have scandium, which is the start of transition metal blocks. Scandium is not transition metal, but after that you have transition metals. Transition metals जो है ना, वो इस ट्रेंड को थोड़ा सा डैमेज करते हैं, ठीक है. They don't really follow this trend for reasons that we'll study in when we do A2. So now we are done with this chapter. We know that ionization energy is the source, it is the proof of shell being there. We know how we can divide those shells, and now we know how to interpret the data of ionization energy. When will it decrease? When it increase? Not just that, we have the power of prediction. अब हम बता सकते हैं, एक रैंडम एटम हमें कोई दे दे कि अच्छा जी मैग्नीशियम बताएं क्या करेगा, तो हम कहेंगे मैग्नीशियम से पिछले वाले को देखो, वो सोडियम है, और हम 4 फैक्टर्स देखेंगे. साइज डिक्रीज कर रहा है, शील्डिंग इंक्रीज नहीं कर रही इतना, चार्ज इंक्रीज कर रहा है, साइज भी डिक्रीज किया, चार्ज भी इंक्रीज किया. ये भी लाइक कोई बात ही नहीं है भाई, मैग्नीशियम विल बी हायर देन सोडियम. अगला आपको आके कहते हैं व्हाट अबाउट एल्यूमिनियम, लाइक लेट्स लुक एट मैग्नीशियम. सो फ्रॉम एल्यूमिनियम टू मैग्नीशियम, size decreases, shielding increases, charge increases. So shielding increase की है और काफी ज्यादा की है. You are changing another subshell, so इसकी ionization energy कम होगी. And yes, you will be right. So अगर आपने hints देख रहे ना एग्जाम पॉइंट ऑफ व्यू से, so जरा hints को देखो. जब भी आप ब्लॉक बदलते हो, पीरियोडिक टेबल आपके सामने है, when you change the, so let me tell you, so important factor, the most important decisive factor. अब ये मैं रट्टे पे आ गया हूँ थोड़ा सा, but एग्जाम में ये शॉर्टकट फायदा देते हैं. So when you change a period, so when the period changes, the decisive factor is greater size and shielding. Effective neutral charge इतना ज्यादा नहीं होता. When you change a group, अब उसमें डिपेंड करता है कि किस ग्रुप की बात कर रहे हैं आप. So when you change a subshell, so the decisive factor is shielding, so decrease करेगा. When you start pairing up, so pair in orbital, when you start that, basically आपने half plus 1 करना है. आपका half हो गया था, subshell half fill हो गया था, उसके बाद you added another one. So the decisive factor there is spin pair repulsion, तो वहां पे decrease करेगा. And if you remember this, आपके एग्जाम में 3 के 3 मार्क्स आएंगे.
So I
You
don't
have to,
understand.
which part?
So the period subshell change thing, like when is the period changing? I don't understand.
It depends. Let's say the question says, explain the difference in first ionization energy between potassium and argon. You'll be like, what is the main difference in them? They are in different periods, right? Argon and potassium, you change a period when you go from argon to potassium. So then you're going to talk about the size increasing. You're going to talk about shielding increasing because of another shell. You are going to talk about charge, but you'll say that's not decisive factor. It's not that important. And so you'll know decrease karega. Because these 3 cases are the ones where the ionization energy decreases. यहाँ पे क्या हो रहा है? Period बदल रहा है. That is this one. अच्छा. यहाँ पे क्या हो रहा है? सबशेल बदल रहा है. यहाँ पे भी यही हो रहा है. तो सबशेल बदल रहा है, शील्डिंग थोड़ी सी बढ़ेगी, चार्ज उतना ज्यादा नहीं बढ़ेगा, डिक्रीज होएगा. थर्ड ड्रॉप कहां पे आ रहा है? The third drop is this one. और ये क्यों हो रहा है? Because you're getting half plus one. You had a subshell that was half filled and you have added one more, and because of that you have increased spin pair repulsion. Now you will encounter, and I'm not saying कि आपकी book भी हो सकता है ये बात करे, आपको टीचर्स भी मिलेंगे और आपको बुक भी मिलेगी जो कहेगी कि अच्छा ये स्टेबल था, अब उसकी स्टेबिलिटी डिस्टर्ब हो गई. आई एम सॉरी टू से दैट इज सो रॉन्ग. दैट इज नॉट द डिसाइसिव फैक्टर. स्टेबिलिटी वी से जब हमें आंसर नहीं आता होता हम स्टेबिलिटी का अलार्म लगाते, बट दीज गिमिक्स वोंट वर्क. वी हैव टू नो एग्जैक्टली व्हाट फैक्टर अफेक्ट्स and how it affects. Do you understand this now?
Yes, sir.
Allah Hafiz.